There we go. So perfect. Welcome to everyone to the webinar today. I'm Bruce Collins, the VP of Consulting Services here at Claigan. I'm talking today about the Claigan EU PFAS Restriction Submission Project. Big name. We don't need an acronym or something. So I'm going to talk about the EU REACH PFAS restriction timeline. What's their timeline to restriction? I'm going to talk about the concept of derogations, which are basically exemptions in the system, the consultation related to them, how you really get what the consultation is, how you get derogations, i.e. exemptions into the legislation for needed uses of PFAS. And then I talk about our project, what we're up to. So program details, timelines, and then what we're planning to submit to the European Chemical Agency, uses of PFAS in articles, PFOA in the environment, review of alternatives, and importantly, at the end, the derogations needed by industry, the uses the industry needs to continue. And I give a full details in the derogation process, how to do it, and how for companies to join. So we started this a while ago, actually, knowing about the consultation. And then a lot of companies asked us to do it individually, help with submissions. And it was a lot of work per company, and they weren't benefiting from each other's knowledge. And we have a tremendous technical knowledge here, both on the chemistry, but also we have a tremendous amount of information on the actual chemicals. And we have a test lab. If you need, of course, PFAS testing, we're easily the best in the world. Please come, feel free to come. I'm going to turn on my webcam because I like to talk with my hands, especially when doing chemistry. There will be a tiny bit of chemistry. One of the reasons I'm going to talk chemistry in here because it explains some of the key points that have to be hammered home with the European Chemical Agency are technical in nature. The difference between good and bad is very much technical in nature. So definitely a big part of what we're going to talk about here. Like the chemical in the top right, that's monopap, E2 monopap. It's a phosphate ester. Probably most people here don't even know what it is, which is fair enough because you would. However, probably at least a quarter of people, maybe a third, if not more people on this call have used it. It is one of the underlying chemicals the longest time on foundation or concealer for makeup. And it's one of the chemicals that degrades into PFOA. And so when you see PFOA in a water system, it's often from this chemical. This chemical breaks down quite easily to it. That's a very technical thing. It's an ester, and there's a reason why it breaks down and the reason why it shows up in drinking water, while PTFE does not. And so that technical element is kind of a big part of it. So we were asked by a lot of companies to do this, and there's a lot of work for them and a lot of cost for them. They didn't, as I mentioned, didn't benefit from each other's knowledge. So instead, we've amalgamated the program into one. So you get a lot more out of it for a lot less cost. You get to benefit from everybody else's knowledge and our, very significant technical knowledge, without every company trying to reinvent the wheel. In particular, it's better for everyone if the derogations, the exemptions are broad and specific at the same time. So they have to be specific to be accepted, but then again, if they are justified in the correct broad manner and take into account more people's uses, then it's a lot more applicable. Not just the parts you have today, but you might pick something in the future that wanders into one of the other potential PFAS situations. So the objective today is to be a 45 minutes, about 15 minutes of Q&A. I'll try to stay on time. So the main thing we're talking about is, lovely slide, on the left, in February 2023, the EU announced they have its proposal for restriction of PFAS. So it's not a restriction, it's a proposal. And the proposal had a bunch of elements in it. And one was basically just ban all PFAS. Another one is, well, ban PFAS with these derogations. And I'll talk about that later, where the initial derogations, like, for ROHS, we often use the word exemption. It's not 100% the same thing, but basically for regulations, there's a thing called derogations, which is its version of exemptions. And so the derogations that were in the initial proposal were things that were submitted to the 5 countries that did their own consultation. So before the European Union or European Chemical Agency did this consultation, there was one with 5 countries. And the submission is not by the EU, it's by 5 EU member states that made it, or 4, I think, plus Norway. Made a submission. This is a proposal. The proposal is not the final version, and it's about as strict as it's going to get. A lot of the work now is this consultation. So between March boom, really fast. In September, there's a consultation with industry, and does this all make sense? What do they need? And there's a lot the EU doesn't know. One of the challenges with all these legislations, what's in the derogations or exemptions is based on what is provided to them. That's been previously provided to them in a REACH registration, sure, it's only so useful. REACH registration is not as useful for physical products. Or it's things people submitted in the consultation. Or it's from other government agencies. It's not, they can't just pick data out of the air or do their own picking of data very easily. There is a separate science committee that can do a little more of their own picking of data. But the EU itself, what's in the derogations and exemptions are based on what they've been told. So it's very important to be told the right thing during this consultation. So this September is really the deadline for exemption requests. They're called derogations. They're like what uses are needed, but that's really the deadline. And you have to justify it. And so it's a really great deadline. That's what all of the projects focused on, that deadline problem. There's still a little bit of an opportunity after that, but it's very, very difficult after this window. It's kind of like speak now or forever hold your peace type problem. And so that's what a lot of this project's focused on, that deadline, getting in what companies need in a way that's effective and has a best likelihood of being accepted and be useful. Having a derogation that isn't useful. So for example, a lot of the ones in the restriction for the longer versions of PFOA aren't, as they're written, useful. Were not written in a way, I know what they intended, but they didn't understand it well enough to understand what they wrote doesn't work. It says, hey, you're allowed it for these ones. Yes, but there's one just on the edge of it, like PFOA, which would still be banned on the way you wrote it up, and that's a bit of a problem. So, or it's like, hey, we wrote it up for radiated PTFE, but often it's a radiated PVDF, and it just wasn't written right. So that's very technical, but I'll explain why it's important later. So getting the requests in a way that it meets the needs of products, especially with trying to limit it to what is needed for products, but also what is needed for the European safety or the safety of the people and environment in Europe, but with also the technical justifications that it's best chance of being accepted. So then from that, we're supposed to publish the comments by sort of December, let's guess. They'll have different dates, but this is usually from practice. Meanwhile, in parallel, there's a science review, a technical review, and it's interesting where that's going to go from because they may not have all the data we have, for example. I doubt they do. And that's going to be interesting. Then there's going to basically be draft text. They expect to be earlier, but that would be shocking. Probably around September of 2024. There's going to be so much published in the comments. Trying to create draft text is going to be exciting. And so there might be a legislative process, probably until it'll probably end soon as May of 2025. They would like earlier, but that's probably not going to happen unless they hive off specific things. And then once they even approve the final text at all levels of government, Parliament, Commission, Council, there's a have your say that has to happen. So the earliest we'll probably see the final restrictions, probably December 2025. They'd like it earlier, but that would be unlikely. And the earliest we'll probably see restrictions is in the August 2027 range. But that means between now and then, there are a number of situations we may have to redesign everything you make unless you get the derogations. And I'll explain that in a bit. In 95% of electronics, complex electronics, so this is like a complicated electronics or like this or like that, have at least one PFAS in there. In most cases, those will be banned under the situation. So it's pretty well 95% of electronics would have to be redesigned in that time frame. Maybe just replacing colored parts, but there's a lot at stake. They don't realize. And one of the problems also has been is one of the main test methods, combustion bomb, doesn't work. It misses 50% of the PFAS situations. It can't see coatings. And that's created a huge gap in the data. And one of the things we have to rectify. It can't see coatings that are not fabric. It can't see the stuff on top of plastics. So that's a big problem. And there's a separate dialogue run by, I think, the Swedish agency Kemi on test methods. And that's one of the problems. Combustion bomb, which they've relied on for a lot of their PFAS presence data, doesn't work for 50% of the PFAS situations in physical products. And that is a huge gap. So that's what's pushing it. So we have the September 30th deadline. And you really have to get in, forever hold your peace, your needs, which hopefully will turn to derogations, which are basically exemptions. Problem is a very short deadline. It's highly technical. You'll see that in a bit. And it's very business impacting. If the rules stay as they are right now, 90% of products basically being sold in the EU will have to be redesigned in the next 3 years. Non-electronics have PFAS a little less often, but they also do. It's currently 95% of all products will require a redesign in the next 3 years. If you can think about the budget impact of that, and it's not exaggeration, this is literally we test, 95% of electronics have at least one part that would have to be changed. And then non-electronics, a little bit less, but still pretty high, up in the 80% range. So we created the Claigan EU PFAS Consultation Submission Project. We probably need an acronym. I'm more of a sciencey person, so we'll have to ask marketing to think about that. But the main thing is, but it's a limited amount of time. By the time we think of an acronym, the deadline will pass. And this has a lot to do with a lot of companies like, hey, you know your stuff. Can you know things? Great. Can you help us with this? And then doing everybody's on their own was a lot of work for just them, and it wasn't nearly as good. So the idea was, why don't we put it all together? Do a much better job for a lot less money for the companies, which seems like a good idea. So derogations, for example, this is what the main focus in the end is, but there's a few things we have to do in between. This is some of the suggestive ones on the far right. And in a restriction, there's these extra columns that say, hey, you can have, like in the middle, there's 6A, food contact materials for purposes of industrial, professional food and feed production up to 6.5 years from entry into force, EIF. Wonderful term. So they get 6.5 more years. And it's proposed. There are a lot of other needs need that. So the idea is to get the submissions in to get the ones they need. Now it's kind of a big deal. And we have up until September 30th to do so. So there are a lot of uses for it. Again, as I mentioned, 95% of electronics have at least one part, usually a lot more, that have an intentionally added PFAS, and even more than that if you add the unintentional. Almost all electronics have at least some unintentional, pretty common. So this is the plan. We want to plan to do 5 submissions, not 5 derogations, 5 submissions. 4 are technical in nature. It's setting the stage. In one submission, the 5th one has the derogations needed by industry with the justifications. The reason we have technical submissions is the EU needs to base their decisions on the technical information they've provided. So if we have good technical information, of course, we have a very high volume PFAS test lab, and we've been testing for quite a while now with a tremendous amount of data. We have things they need to know. And if we're going to base it on a reason, this information would be very useful. Like, where is PFAS found in articles? We know a lot now. Where is PFOA found and why? It's actually a big deal. Why is a big deal? The one that everything is blamed for, PFAS gets thrown into this bin because there's a small group of them, the PFOA family and similar, that are surfactants that in high concentrations, they affect the protein surfactant in your kidneys, create kidney function or kidney cancer. And they say, it causes this, heart and head and everything. Your kidneys fail, they cause all the other problems. It's just around the surfactant nature. They affect transfer of basically materials across water, fluid barriers, and bacteria in that section. And that's why they're dangerous. However, only some of the PFAS polymers create them, some do not. And they're perfectly safe. Probably, if the EU passes it the way it is right now, they will injure or harm hundreds of thousands of EU citizens. They don't know enough. And this is one of the technical submissions, is what are the alternatives? Why the main alternative has 10,000 times the concentration of forever chemicals. That's one of the kind of things, I always call them forever chemicals. PTFE is not a forever chemical. PFOA, if it was in it, which it almost never is. However, silicone, PTFE's potential replacement in some situations, averages, we test all the time, by the way, 10,000 times higher concentration of forever chemicals than PTFE ever has. So that's an interesting thing. So they need these technical submissions. They make a justification that, hey, why this is safe, way safer than the alternatives. And PTFE gets the blame for a lot of things. PTFE has one danger. If you heat it up to about 600 degrees Celsius, it'll start to burn, and it'll release hydrofluoric acid and carbon monoxide. Carbon monoxide can kill your birds, pet birds and such. But if something's going up to about 400 or 600 degrees Celsius in your home, you have other problems. Otherwise, it's probably the most benign substance out there. So the project, the idea is companies are invited to participate. There is a cost, but it's far more marginal because of the way it's structured. And the project runs from July to September. It's a really tight window. We also don't expect you to do a lot. We want to make sure that you know what's going on, you get your uses in, we can verify which derogation your uses are under, we'll explain and educate it, but we're going to do most of the work. We kind of have the background, we both have the testing ability and obviously the chemistry stuff. So the submissions we're doing, there are 5 of them. I'm a little vague right now, I see. So the first one, we're actually saying, hey, where are PFAS in articles? Like, where are we actually finding it? And the most common situation is a little aerosol can, and you have foam or you have an O-ring. Almost all your O-rings have this, by the way. You have a mold. You put whatever the goop to become the O-ring is, and you mold the O-ring. Unfortunately, the O-ring will be nitrile rubber, or EPDM, or styrene butadiene rubber. It will stick to the mold. So they spray it with mold release. It's like your muffins. Like when you make muffins, you put the muffin batter in. If you just put it in there and you cooked it, it would stick to it and you'd be chipping out the muffin. So either using a Teflon pan, which already has a release, it's low friction, or you put like butter in or some mold release agent or PAM, or you put a cup in between so it releases from the muffin mold. The same thing with your O-rings and your polyurethane foam. They needed to be sprayed so they release the mold, and they spray it with a little can, a magic can of fluorosilicone polymer, and they end up on the surface foam. Most of them, the majority actually. So if you have an O-ring or gasket in your product, more than half the time it has a PFAS above 50 ppm, just so you know. Extremely common. And unfortunately, combustion bomb can't see it because it incinerates the whole product and can't see the surface coatings. And of course, if we're worried about getting the environment, the surface coating is the most important thing in the first place. And this, it's a mold release, so it gets on everything. By the way, when you, your stickers, most of your stickers, not most, maybe 30 of your stickers have PFAS in them. Like, what do you use PFAS for? It's not the sticker's fault. Well, a lot of your stickers come in a roll. That roll is a release paper. That release paper is often fluorosilicone, and some of it gets onto your sticker or onto your silicone pad, your heat pad you put in there. And so it's got unintentionally added, that's unintentional, fluorosilicone from the mold release tape. Yeah, so you know your stickers, they come like a spool, and you peel off the spool. That spool is often fluorosilicone, and it releases fluorosilicone onto the adhesive and above 50 ppm. So where is it? So we'll explain where they all are. There's also like PTFE wire, and then there's one of the most common ones is ABS and polycarbonate. When they burn, they would drip. It makes them, they can't pass UL 94, V0, or V1 if they drip under fire. So they have PTFE. PTFE, when it burns, creates a webbing so it doesn't drip. Kind of an important thing. If you got rid of that application, there'd be a lot of problems. And so requalifying a new flame retardants or anti-drip agents would be time consuming. So there's a good justification why industry needs more time, because it's not the easiest thing in the world to replace. And if you did, having to redo the fire retardancy of every electronic or similar product into Europe would be not a 3-year thing. Okay, and so where are PFAS? Next one's, where's PFOA come from? It comes from a limited number of situations. And I'll explain a little bit that later. So I'm going to explain each one of these in a little more detail. We're the dangerous one at ridiculously low concentrations, by the way. I mean, putting all your PFOA into the river from your factory, that's not a good thing. But where you actually see it in your average water supply or drinking water, when they say, hey, we found it in this nanograms in our water supply, is not what they think it's from. Kind of interesting. If anybody ever get into a lawsuit and they're saying, hey, your products put this in our drinking water, if it's not related to your factory, come talk to us, because we can usually tell by the signature of what they're measuring. Once they see PFDA, O is octa, N is nona, D is deca, 10. Once they see PFDA, it's coming from one thing, and it's probably not you. So we're talking about, where's PFOA going in the environment? That's a big thing. And eventually they say, hey, it's all exposure. So we want to set the stage like, well, here are the main areas where you could have exposure. These are the ones don't. And so if they don't have any danger, they don't expose PFOA in the environment, then why are you banning them? And then we're going to go on to explain a lot of comparison alternatives. Here are all the different alternatives. By the way, most alternatives are way more dangerous, way more forever chemicals. You want to use the word forever chemicals? Silicone has got 10,000 times the higher concentration. The EU a couple of years ago declared D4, D5, and D6 siloxane as forever chemicals. They're the building blocks of silicone rubber. Silicone rubber is literally cured versions of that. The average silicone rubber has around 500 parts per million D6. So forever chemical. PTFE rarely has this as an additive. PTFE almost never has PFOA. If it is, it's in the 50 parts per billion range. 50 parts per billion versus 500 parts per million. It's a 10,000 times concentration difference. Forever chemicals, PTFE is about as good as you get. Silicone is pretty bad. So you gotta be really careful what you're replacing with. Polyurethane can't do certain things. Silicone is not as water resistant as PTFE, and it's not oil and stain resistant. Oil stains go right through it. Oil go right through silicone. So on and so forth. But we also compare the different PFAS. There are reasons why you use the irradiated versions. They have real uses. They actually have PFOA in them at the end, which not a lot leaches out, but they have some because they got irradiated, and I'll explain that later. But there's some really technical reasons why it's needed in some cases in closed systems that aren't, exposed to drinking water, and going through all those different alternatives. And so we do a summary. I'll explain that later in a detailed version. And then here are the derogations we need, which is really what industry is looking for. I want my uses so I can keep using them as long as technically feasible. But the EU's got to base a lot of their decisions on the technical information. And the technical information's in there, they can't ignore it. And by the way, they have to use the information that's provided. So the US can also use the EU data. Once it's in here, it sets the stage of other jurisdictions, US, Minnesota, Maine, whomever, Canada, to be able to use it. And people talk about the US emissions. US emissions are by CAS number. We can do the same thing, but in a different direction. But considering this restriction is far more up and coming and business impacting, we're focusing on the European Union first. So I'm going to talk about each of the submissions in detail. What are the advantages of our project for you, your company? Well, first one is you get to actually include your uses. So right off the bat, we'll say, give you an Excel sheet. What uses do you have? If you don't know them all, it doesn't matter because you're going to have a lot with other people. But at least let's set a starting point. You provide it to us, and they're going to identify what derogation they're under. So you said this. Sometimes this will be under a C2 derogation, C2, C5, C7. So then you know what derogations to follow as you do. You're probably doing 25 or 30 of them. You know which ones are important to you. And then as you see everyone else's, you might then get a better update. Wait a minute, I have that one too. You're also going to get the opportunity to review and comment on the submission before we do them. We're going to build them, by the way. We're going to build them up. You're going to provide us extra information so we don't miss anything and get feedback, especially with language or detail. But we're going to do all the heavy lifting. There's going to be a monthly web meeting where we're going to tell you where we're at. This is where they all are. And we're going to provide education as we do it. When we're asking for, say, these derogations or these uses, this is what it is. Let's explain it. So it'll be easier for you to comment on than that one sentence about, this professional use of elastomers, et cetera. Let's explain what I'm talking about. And sometimes you're like, wait a second, I might actually use that. Or, you know what, it doesn't really encompass this use. And you provide feedback on that. But we're going to explain what we're doing as we go. You're also going to get the submissions in draft form to comment on and final versions. So you're going to get to see them. And you also get to show other stakeholders, the companies, what's going on. So, where I am doing something, this is where our uses are being covered. Oh, and you also can show how serious it is. These are all the things that can be banned for us. This would be very expensive for us. You're making sure that it doesn't become a massive, expensive adventure. And you can keep doing, which is designing and selling your products. And then we'll eventually submit the documents to the European Chemical Agency, and they'll be on in their official record. Both the technical side, which a lot of things, when they write up anything in the future, they're going to end up having to reference the technical references, and this provides a lot of technical references for them. They'll keep reappearing in any PFAS discussion, Europe or otherwise, for the next decade or two. So it's very advantageous. We're only 2 cents worth, and especially, and as important as derogations are to make, believe it or not, the technical ones are going to be the justification often used in other jurisdictions because they'll look at the European, official data and then use the same stuff. Because if Europe's accepted it into their system, then it's easy for the US to use it, or Canada, or any other jurisdiction. So that's one of the main advantages. So what are the submissions? By the way, there's going to be a Q&A at the end because there's a lot going on here. We're first going to talk about PFAS and articles. We're literally going to go, we start with basic graphics because pictures, tell 1,000 words or some such thing. Then we're going to explain each one. What's a release agent? What's sprayed on your mold so your O-ring comes off of it and it's on your O-ring, it sticks to your O-ring. What's an anti-drip agent? It's not to stop it from dripping water. It's literally when it burns so it doesn't drip. So the UL 94 or the CSA Canadian equivalent or the low voltage directive in the EU, it's basically one of the flammability tests is Bunsen burner, put the plastic on top of it. There's two things that go on. Once they move the Bunsen burner away, the fire is supposed to extinguish in a certain amount of time, and they have a stopwatch, and that's extinguishing, and that's one thing that sets its flame rating. The other one is whether it drips burning plastic. If it drips burning plastic, that also negatively affects its flame rating. The anti-drip is PTFE added, so it creates a webbing so it doesn't drip anymore. Very handy. Internal wire coating, a lot of your hookup wires, you might know or not, are actually sprayed with the same mold release that releases from the mold, this magic can of spray. I think it does everything. You ever see the uses list on the back of that thing? It can do anything. And it's sprayed, and so the internal wires, like PVC wires, have lower friction between each other, so they're less grip, so they're more flexible and they're more durable because they don't chafe against each other. Really common. Some use PTFE parts, everything from the electronic side where your antennas or your coax cables have a PTFE shaft. Your antennas, if you have antennas on your products, they have usually a PTFE shaft for dielectric constant. But it could be a medical device that uses a bearing. There's a whole bunch of uses for PTFE. PTFE wire. So PVC wire is probably the most common hookup wire, but PTFE wire is really common, especially as people are trying to get away from PVC, from other regulations and plasticizers and its problems. A lot of them move to PTFE, which is a very benign, harmless wire. Then there's PTFE pool tape, and coatings on top of silicone, and then there's Viton gaskets and seals for chemical situations. And there's another one is some of the plastics, rigid plastics we use in a moving situation. They add PTFE to the plastic, like the nylon or the polyethylene, to create more lubricity, slipperiness, so the part slips a bit. It's not coated, it's actually part of the plastic. So what we do is explain all of these things. This is all based on test data. Like everything you could imagine in the articles, products, anything and everything. Could be a computer, it could be a water filter, could be a chair. It's a huge variety of things. Tons of medical devices, so on and so forth, handheld electronics, multimeters, it's everything. So this is based on what's really there. We're not making assumptions on what's coming out of China or whichever. We actually test for it all the time. We do, hundreds of PFAS, well, we'll probably do 500 PFAS tests a week, if not more, very specific. So we have a tremendous data set. So that's going to go in there. So this gives them a basis, like they have to make sure they've addressed all these pie pieces. They're like, oh, will this affect the operation of the European Union if we lose one of these? So by submitting this technical, why we're submitting 4 technical ones, it forces them to have to account for these situations. So instead of blindly saying, you know what, we're getting rid of bad things. Okay, you're getting rid of car batteries. So one of the funny things, you ban PVDF, you ban PFAS broadly, you have no electric cars anymore. So remember that whole thing, you have electric cars page, no, you can't have it anymore because PVDF is the main binder in the cathode for all big lithium batteries. So you can't have electric cars anymore. It's not in their derogations, by the way. The way it's structured right now, they ban electric cars, which I don't think they know they're doing. So there's a lot of technical stuff they need to know. Sources of PFOA. So this is another one we have to look at where PFOA actually is from. So it isn't like, hey, PTFE, people say, hey, Teflon degrades into PFOA. I'm like, no, it doesn't. Not even remotely. They look at you blankly, no, it doesn't. It's not where it comes from. This is where it comes from. So PFOA is the one that can cause problems. It's a surfactant that affects the kidney function, can affect your kidney function, high concentration. Probably not the low concentration that is in drinking water whatsoever, but in high concentration it can. It only comes from certain things. PTFE can have it as an additive surfactant during manufacturing, but it never does anymore. Once companies have gotten all these lawsuits for PFOA, they ditch that. They might use PFHXS, which is a sulfonate in the PFAS family. However, it is super easy for them to scrub out and doesn't exist in the final product. So it's not in manufacturing anymore, especially with the lawsuits involved. It's gone. So where it's coming from is from another problem. It's not an ingredient. They're all, we'll say, degradations. One of the most common is irradiation. It's the one on the bottom right. So PTFE, this is ABS, by the way, ABS polycarbonate, is rigid. It's a very, very long polymer. The longer polymer, the more rigid it is. It makes it fairly inflexible. PTFE is actually relatively inflexible. To make it flexible, you have to cross-link it. So your car tires, for example, which are Styrene, butadiene, rubber mix are cross-linked, and that's why they're not rigid, solid like a plastic. They're cross-linked and like a rubber. So what they do with PTFE is you have these long chains. They irradiate it with gamma rays. The gamma rays break up the PTFE chains, make them smaller. Then the chains recombine. That's why I have a camera on, by the way. It's very technical. Like that, or like that. And so now they're not straight and rigid. They're in different directions. It creates a rubber. It's this solid, rigid. It's rubbery, and it rubberizes the PTFE. Unfortunately, when it does that, when it breaks up the chain, some of these little chains in air react with the oxygen and form carboxylates, which are oxygen-based, like PFOA. So when you irradiate PTFE powder, which is common in plumber's tape, pool tape, or in you making expanded PTFE, often called Gore-Tex, not necessarily them, they often irradiate the PTFE so it expands into a fiber. It makes it rubbery. When they do that, they create PFOA. Now, it doesn't degrade from then on. It's just a single event. When it's irradiated in gamma radiation, it breaks up, reacts to the air, and that creates PFOA, and it has what it has. It doesn't further degrade. So PTFE can have PFOA because it's irradiated, and it gets not just PFOA, it gets every length. There's no length. It gets PFBA, which is 4, PFPA hex 6, 8, 9, 10, 11, 12, 13, 14. It gets all of them because it's just randomly split. And that's where PFOA comes from in physical products now. It's almost always either irradiation or it's a PFAS ester. One of the big things we have to do, and you'll see on the next slides, is explain to the EU what a PFAS ester is. There's a difference in PFAS and PFAS ester. PFAS esters, which I'll explain again in 2 slides, have a very weak bond. It's called an ester bond. It's an oxygen. Yes, this is very chemistry, but it's really, really important from like things that may or may not be banned in your product. An ester bond basically takes one polymer and duct tapes, I'd say Scotch tape, maybe staples, a fluoropolymer on. This is PFA perfluoroxyalkane. It's a flexible version of PTFE, but it's not PTFE. It's got this ester bond. It breaks the ester bond. That piece pops off. Like the radiated PTFE, this popped off piece reacts with oxygen and creates PFOA, and that's esters. PFAS esters are very different. Main thing we see PFDA. So when you ever see PFDA, PFOA is 8, PFNA is 9, PFDA is 10. When you see that in drinking water, that's usually from, there's one major source in out there for that, and that was, until about a year ago, maybe 2 years ago, phosphate esters in cosmetics. Since PFOA has been banned, they've been removed. We tried to acquire a whole bunch last year of makeup with it, which still had C9 to C15 fluoroalkyl phosphate, which is phosphate ester on the ingredients. By the time we received it, it was removed from the ingredients list. But those degrade really, lots of science papers. Basically foundation, especially the higher SPF, concealer, all that kind of stuff had a phosphate ester. It easily degrades into PFOA because it's the weak bond. And if you think about all of the foundation used by all of the people in Europe over a given year going down the water supply, it creates a lot of PFDA. So when you see PFDA in the water supply, if it's not related directly to a factory, it's most likely the cosmetic use. Historical, it's been actually removed now. So when I look at data, I also look at when was that testing done? Oh, it's more than 2 years ago? Yeah, it's not the current situation. So then we do a submission about this PFOA in the environment, which is a really important thing, talking about phosphate esters in particular. This is a very important thing. We need to know the difference. PFAS non-esters, like Teflon, and esters are very different. The PFAS esters degrade into PFOA. Teflon does not. Unless it was irradiated, and it just gets that PFOA and family at the time it got irradiated, it doesn't have any. It's inert. It doesn't degrade. The thing is, one of the benefits of a forever type chemical is it doesn't degrade. It is what it is. PTFE is like, well, you know, it can degrade, yeah, 400 or 600 degrees Celsius, but if your house has something going to 600 degrees Celsius, you have bigger problems. So non-esters are a negligible source of PFOA in the environment. This group is inherently safe. When we do the comparison alternatives, the non-esters are incredibly safe compared to the esters. The esters break down to PFOA. So whether or not that's the phosphate esters you see in cosmetics, or when you go waterproof coating on your jacket or like your barbecue cover or whatever, that one is a phosphate ester. And the ester has the weak duct tape. And so we'd have to explain this a lot more in the papers. Oxygen bond, and we can easily, whenever we see these, we usually measure PFOA. because that weak little bond snaps and it creates all the PFOA family. It's just a weak bond. That weak bond, by the way, in a very different chemical family, DEHP, which is not a PFAS, is the phthalate that's been banned in ROHS and all these other things. It itself is not dangerous. It's only dangerous. DHP is only dangerous because when you metabolize it, your metabolism breaks one of the two ester bonds in it. Again, it's got the duct tape ester bond, and it becomes a chemical that looks like estrogen after that bond is broken. And that creates a problem in the development of children in the first year of life, which leads to attention deficit. Again, it's the ester bond. When we look at the harm of a lot of these chemicals, it mostly comes back to an ester bond, because the chemical itself is not dangerous, but when that ester bond is broken, it creates a new chemical that generally is dangerous. DHP becomes mono ethyl hexylphthalate, which simulates estrogen when its ester bond breaks. When these guys' ester bond breaks, they create the PFOA family. It's a big difference between ester ones and non-ester, so we have to explain all that. Because when you want to say, hey, there's a reason I need this, it's not the dangerous one, that's those guys. This is perfectly safe. And a lot of it's to set the stage for needed uses. And big things like saying the danger, like we really need this and it's a huge advantage. There's no replacement for it, no reasonable replacement. And it doesn't produce anything dangerous. It's a safe one. Its alternatives, not as safe. If you're blaming all the stuff in drinking water, that's the other guy. That's not us. And that's a big part. All PFAS, people say, hey, it's a zillion CAS numbers. Really isn't. In physical products, it isn't. There's a handful of polymers or copolymers, and then a handful of basically breakdown products, carboxylates and similar. But you're talking about 20 different CAS numbers total in reality. But there's a huge amount of stuff that's blamed for a small number of them, usually the PFAS esters, on everyone. And Teflon itself is pretty big deal. So then we have to do comparison of alternatives. This is, I don't think they understand. Because the other advantage of a lot of test data is we have a lot of test data. And we also do a lot of work in replacements. And so we both have a summary and detailed version where we look at, a whole bunch of different criteria. There's actually more than what's here. This is just a simple summary. And we look at, the advantages of each. And each one will have a larger breakdown, explain what we mean by it has excellent low friction properties. It's got excellent chemical resistance. It's got excellent water resistance. It's got oil. PTFE is not the most flexible. Decent. It's not poor. It's decent. Peak, poor flexibility. Peak is not as good for coefficient of friction. It's not as chemically resistant. It should be chemical resistant, not restriction. Forever chemicals. PTFE is the best for forever chemicals. People go, but aren't they banning forever chemicals? Yeah, PTFE doesn't have that unless you're radiated. They don't have any. It's wrong. It's the other guys. That's actually one of the biggest things. It gets forever chemicals, so PTFE is good. Silicone, huge forever chemical problem. PFA, which is a fluoroxy ester version of PTFE, it has a bit of a forever chemical problem. Irradiated PTFE has some forever chemicals, but they don't really come out. ePTFE, which is like the expanded one, your PTFE fiber, it's got a bit of a problem because it gets irradiated. Fluoroacrylates, not so good. So this is your waterproof coatings on jackets and outdoor furniture coverings and stuff like that. It's got a bit of a problem because it's a fluoroester. So it's very different. And they have a lot of different properties, but there are sometimes reasons why you want to use PFA. It's got better flexibility than PTFE. So in some industrial applications or chemical resistant applications, it's actually more chemical resistant PTFE. If you have this chemical jar and you need to be absolutely chemical resistant, PFA is the way to go. PFA is definitely it. There's a little bit of forever chemicals, but it's holding in it the nastiest chemical you can imagine. In our lab, there's a good reason why we have some PFA jars and stuff like that, because there's a chemical in there we don't want it wandering around. But this is not a drinking water issue. This is literally to hold in. It could be the bottle. Actually, the chemical comes in is PFA. There's a reason for it. It might have a little bit of PFOA, but it's not going anywhere. It's the bottle for a very dangerous industrial or professional chemical. There are uses for PFOA where the PTFE wouldn't be good enough, and polyethylene would just get destroyed by it. So there are uses for these things. Yes, it has a bit of forever chemicals, but we go for the derogation in these uses. It's got a very, very important use, and so this is not a drinking water issue. It's got a tiny bit of PFOA in it, but it's not getting into the environment. This is a very restricted application. So a lot of things like that. So setting the stage of what things are, polyurethanes, friction is awful, helps justify why we need certain things. Biocompatibility, still use medical devices, but almost every single 10993-18 test report we ever see, at some point in time, if they have a silicone part in there, there has to be toxicological assessment why all the D6 coming out of it is not going to poison the user. All the time. It's approved for medical, but it always leaches stuff into the patient, not at a dangerous level, but always does. So it's not poor, it's not approved, it's just decent. Because anything that consistently needs a toxicological risk assessment when doing medical exposure doesn't get the excellent rating. So it's not that easy. Now, PTFE does have another one, which isn't here. It's medical side. It does have another problem. It can't go anywhere near radiation sterilization. Gamma radiation sterilization, which destroys PTFE. As we saw earlier, it breaks up the chains. It can't radiate. So it's stuck often with autoclave or ETO. ETO has its own negative connotation, sterilization. So there are other limitations of it because it's broken up by the gamma radiation. It'll turn into a puddle. It'll lose 98% of its rigidity if you try to sterilize it. So all of that kind of comparison. It's very technical. So there's a top level, so they can easily reference and they go, wait a second, that was a lot of pores. So it's a simple answer, and then there's a deeper answer inside. And then eventually derogations, because that's what industry is really looking for in the end. But the idea is we need to set the stage, technical information. When we say things, they're like, well, that isn't true. Look over there, it's right there. See, this is the explanation. They're like, oh yeah. And if there isn't data as good or better, they have to use ours. It's one of those things. So it sets the stage to allow easier approval, especially of broad derogations. We want derogations to be technically specific, however, to cover the broader applications, because sometimes there's a little detail between one company's use and another's that really needs to be included. Otherwise, we're just going back to the drawing board later, which we're seeing with a lot of the derogations so far for PFOA and similar, where like that was drawn a little too fine. It doesn't actually work in practice. So then we do the derogations. And so we have to do a summary version, a short version, so they have an easy reference sheet. And also you have a reference sheet. So when we say, hey, yours is covered by C1 or C2 or C3, we just made up those names. You can easily look at it, but then it'll be detailed. What is it? What's its use? What's its justification? What's its timeline? Like, why are we asking for 6.5 years? Which basically means it has a replacement, but the replacement will take some time to qualify. So 6.5 years. Or there's no known effective replacement. It's 13.5 years. And that's a renewal process too. So anything you can't get forever them is 13.5. So, but there is another renewal cycle 13.5 years from now. So like there's a reason why, hey, we want the fluoroalkyloxyalkanes, the PFA polymers. So that's the PTFE with a little ester sticking on the side. In professional application, not in contact with drinking water or food, maximum of 2 ppm of, it will also have the C4 to C14 before alkyl carboxylates because of the way the ester degrades. However, there's a lot of, we try to make it broad, professional applications. We could restrict it to chemical, but it's used in medical devices and a variety of other applications, professional applications, where we're saying, why don't we go for the broad one? And we'll explain all the different ones inside, but we'd rather go for the broader version. Fluorosilicone release agents used in manufacturing process of plastic and rubber parts. That's the mold release. So it's replaceable, but it's gonna take some time. So at least go for 6.5 years. And if it isn't replaceable a couple of years from now, we can probably do a resubmission, but it gives you time. Between how long it takes the law to get approved, they'll give you 7 or 8 more years. PTFE used an anti-drip agent in plastics to meet flammability or safety requirements. 13.5 years, because there isn't a replacement right now. And it's a major undertaking. And it affects the flammability of all the products in Europe, and that causes more immediate death and destruction than, and PTFE will also say, hey, meanwhile, PTFE used in there is not irradiated, it doesn't have PFOA. We measured all the time, no PFOA in it. There's nothing hazardous about it, perfectly safe, and it stops things from burning. So perfectly safe, well approved, and stops things from burning. Don't be getting rid of it. Now, you can't say forever, 13.5 years the most, but it's a renewal cycle. So, and then go through all the derogations. And of course, we created draft versions, we get your feedback, we modified a bit, fixed the English. I'm sure I butchered some of the English. I'm good at esters, not English. So what do we do in the derogation process? I'm not gonna make the 45 minutes. I'm gonna be closer to 50. PFAS, so you submit. There we go. That's not quite working. So you first submit your uses. And we have also derogations because we test all the time and we do a lot of stuff for main reporting and soon the Canadian federal reporting. We have a lot of data, so know a lot of the uses. So participants will submit their uses to us. We'll have our initial ones also. We're going to review submitted to see how it fits into the ones we have right now or adds to them. We're going to merge them into a draft derogations list. So take what we have already, because we have a lot, not really dependent on you much, but we'll take what you have and we'll definitely also tell you what we're doing. Then we'll do the research on uses and justification. You'll be able to provide feedback, and if you have more information, we'll always take it, but we're going to do the heavy lifting. And then we'll actually explain the draft list. We'll have a web meeting explain this is our draft derogations and why. And comes to make a wait a minute, that, oh, that does cover me, or oh, that's why my use is in there, or that doesn't cover all my uses. Feedback. And then from the web meeting, then we circulate the first draft of derogations. So this is what they are. And then we get your feedback. And then we may update the derogations, the uses, the justification. We go into a lot more in detail. We have to have references. There'll be some science references, our own test data references, lots of other good stuff. Then we'll have another web meeting to explain the updates. Meanwhile, there will be, in some of the web meetings, we'll talk about the other submissions also. And then we'll circulate an updated version. And then we'll get final feedback. And hopefully, it won't necessarily be perfect. It'll be like 95% good, with 100% good, as usual, because it's a really tight time frame. Eventually, we have to, cut bait and go fish. We'll do the final updates, and then we'll submit. So also, when you submit yours, which I showed early on, one of the things I didn't show here is we'll submit back to you which one of the exemptions we're covering under, so you know what to follow. And if you come up with one later saying, wait a minute, I also have this one. Oh yeah, okay, don't worry, that's under C7. Or that's a new one, and we'll ask more questions about it. Usually we'll have a lot of what's going on. The test data helps a lot because we see a lot. Sometimes your use is more specific, like, oh, that's why it's there. It's theoretically there, but you also use it for this other reason. Oh, excellent. Okay, so we'll add that in. And then we'll do the submission. So the advantages again, you get to make sure your uses are included. You get to show internal stakeholders your uses are included. Like, our things are being covered. This is where we're at. We have a status plan. We'll have monthly meetings to explain it, because there's going to be some explaining. I hope everybody will follow it on the irradiation, the ester section. And you guys are way more knowledgeable than the average person, but it's a lot to take in, and it's going to get worse. But sometimes if we're going to esters, it isn't just for fun. Well, it is partially for fun, but not just for fun. We all have our versions of fun. There's a really good technical reason why the esters need to be segregated from the others. Their risk profile is different. I don't want what's imperfect, not so dangerous, imperfect with them to affect what's perfect with other uses. And then you'll be able to see the submissions. So we'll have the draft versions. You can circulate with other people and show stuff's going on. But also make feedback, fix my grammar. Well, people probably hear grammar all the time. Poor souls. And then final version. And then we'll have the final version, and then we'll submit. So you'll know where everything is. You'll have some confidence that things are being taken care of. You'll also get to leverage what everybody else is doing. And as opposed to often like an industry group, we're not requiring on you guys as a working group to figure it out, which also take forever. We really have, like, honest to goodness, we have a test systems over there. Like, there's a lot we can do. We have a question, like, you know what, I can sit there and research it for a while, or I can just bring it over there to the lab and double check a few things. It's a lot easier. Again, submissions, we're doing PFAS. We have 4 technical submissions to set the stage. Where's PFAS in articles? Where's PFOA in articles? When we're seeing stuff in the PFOA in the environment, you're saying drinking water. Often they say PFAS in drinking water. One of my favorites, about a month ago, The Guardian, a very good newspaper in the United Kingdom, said, hey, PFAS linked to infertility in women. I'm like, it's kind of a big statement. Yeah, pretty hard for Teflon to do that. So you go into it and you follow it. It takes a little while because then they talk about PFAS and Teflon. I'm like, la, 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 la. And eventually get to the science paper. And the science paper is actually really fascinating. It's out of Singapore, I believe. And what they did is they tested women's blood content for the PFOA families, which makes sense. They are PFAS, fair enough, but it's PFOA family, and the longer versions of PFNA and PFDA. And it linked it to women's fertility rates. It's quite a good study that way, but it's not PFAS. They're testing for the PFOA family. And the most correlated one is PFDA. PFDA has one major source, especially in women. It's the breakdown product of the phosphate alkyl ester in foundation. Now, not anymore. The makeup companies did a great job and got rid of it. We tried to test it and find it. They punted it a couple years ago. But this study is, of course, from a couple years before that. So PFDA is out for makeup. Now, it's not saying it causes. All they're saying is we found it in the blood of women with lower fertility. So the real headline shouldn't be PFAS linked to infertility in women. It should be women with lower fertility rates have the biomarker of heavy makeup use, which is, by the way, a very different story. Whatever you think about it, it isn't necessarily causation. They just have a biomarker of heavy makeup use, and there could be a lot of other things at play, not just chemical, social environment, so on and so forth. It's quite different. So often when they say, hey, we found PFAS in drinking water, we're like, which one? And when they say PFOA, PFNA, PFDA at roughly the same concentrations, there's only certain things can do that. That's an ester. The esters break up evenly amongst them. So if they're all roughly the same level, that's esters. If it's one of them, it's an ingredient. If it's all of them, it's an ester. Comparison of alternatives. It's kind of the big hint. So when we see a drinking water study, we see, is it just one of them or is it all of them? If it's all of them, it's an ester breaking down. If it's one of them, it's an additive. It's quite different because they don't add the family. They add one thing. They add PFOA or PFHXA or one of the polymers. They add one thing, which can break down into one or two things, but it's very specific. But if you see all of them, that's an ester. Comparison of alternatives, and then the derogation is needed. So really simple, setting the stage. I hope everybody learned some bits here. I was talking a bit fast, using my hands. Get to play with my ring. Tungsten, not conflict. I know the cyber business. So again, when in doubt, want to join, contact us. The costs are very straightforward. It's not very complicated at all. The main cost is for the whole company, because you're going to get documentation. If you want other business units to interact directly and interface, there's a fractional more cost just because extra project management. But that's it. It's really straightforward. We don't have time to dicker much about the cost. There's a time frame going on. Of course, there's a picture of PFDA on there, which I find fascinating. It's the one that breaks down from the phosphate esters in makeup. It also can be in the irradiated materials at low levels. At this point in time, the business folks probably want me to focus on, contact us and join. I just like the chemical. But definitely just reach out. It's really straightforward. Like, it's not complicated. It's not a salesy thing. This is what we're doing. This is how much it costs for a company. Do you have any separate business units that want to interact directly? If they're all going to go through you, that's fine. It's one cost. It's just interacting with multiple groups just sucks up some time and energy. So again, that's the big deadline, September 30th. So you can't really wait around too long. And the sooner you get in, the sooner you know stuff. So it's really good. Again, but do Q&A. Feel free to just contact us or contact me or the webinar email or this one. It'll go to people who know stuff. And generally know stuff. There's also a web page on it that gives a little more description, sort of. This page is pretty good itself. And now Q&A. So if you have any questions, please feel free to submit it in the control panel. I'll try to get to as many as possible. If not, I will just feel free to contact me afterwards. Will the slides be available after the talk? Great question. First, yes. So a couple things. Everyone who registered will receive a copy of the slides. Also, there will be a recording of this available online, probably by Thursday at the latest. So there'll be a recording of this, so everybody can rewatch it. Also, nice thing about the recording, you can literally, I apologize. It's like I'm French second language. I could not keep up to my speed of speaking in French. You can also slow it down in the recorded version, which my one British fellow here, awesome guy. He's like, he found that out. He could slow it down. He's like, he stood up like, oh my God, I suddenly understand him. So that's a good part here. Yeah, so everybody who's registered will receive a copy of the slides, probably by tomorrow at the latest. Can you comment on polymeric PFAS are being included in legislation? Yes, so all PFAS, including polymers, are included. Polymers are being regulated at 50 parts per million fluorine, as opposed to specific parts per million and parts per billion of specific CAS numbers like PFOA, which are 25 parts per billion. The polymers, the derogations are also broken too, by the way. There are derogations for polymers and non-polymers for certain applications. Like, so if you ask for PFA, you need a derogation for the use of PFA oxyalkane and the range of PFOA family that will be in, and we recommend up to 2 parts per million total. So it's both, and there are other ones like in food applications where it's just the polymer itself and there's no exemption pan has PFOA in the Teflon, but that's fine. The PTFE in your fry pan has no PFOA. They don't want to be sued about PFOA. There's lots of other alternatives. They use a different additive. So pretty straightforward. Question: our primary concerns are PTFE, FKM, and FFKM. So FKM is the soup. We're just going to call it fluoroelastomer because it can be a whole bunch of different homopolymers, usually with vinyl fluoride. We're going to call it fluoroelastomers, and give some description. It means this. The fluoroelastomer family, it's not like a one size fits all. They're usually homopolymers or copolymer rubbers with vinyl fluoride, but there's a lot of stuff going down. So we're going to call all the FKM, which is an old German term, and FFKM, which is a variation of FKM, often called Viton. We're just going to put it in the fluoroelastomer group because they're basically all the same soup. It's kind of neat to test them where, PTFE is very distinct peaks, and once you get to FKM, it's just like this goop of stuff on the spectrum. It's kind of neat. PTFE is definitely included. I can see why you'd regulate to a certain extent the use of a radiated version because of the PFOA, but the main PTFE is as benign as you get. Is there a standard definition for PFAS? They're always wandering around. It basically means, if you look down the middle here, there's a couple chemicals there. It means it has to have that carbon fluorine. So you have to have carbons attached solely to 2 or more fluorines and carbons. It can't have a hydrogen or a chlorine or whatever. Once you get one of those, and the PFOA is like 8 of them, I think that's PFDA at the bottom. It needs to have that carbon fluorine. There's 2 or 3 fluorines on a carbon, and nothing. It's not attached to any hydrogens. It can only be attached to fluorines and carbons, of which the PFDA has a ton of them. There's some medical drugs that have 1 fluorine sticking out. That doesn't count. It has to be a methyl or methylene group. It has to be carbon with 2 or 3 fluorines, and the other bonds are only carbon. So that's kind of important. How many companies are participating in the consultation? It just started. So there are people in the joining process, at least half a dozen right off the bat, but it's growing really fast. So it's very, very new. I mean, we just released it here. A lot of other people, because they're doing other work, and it's going from there. Are you going to protect confidentiality if companies provide use information? Well, yes, we're going to blender it together. The idea is your uses have to go in there, but the idea is to blend it together. We're not going to show your submissions to anyone else. We're going to say, hey, that's your use. It's under C2, and C2 is the blended version of the derogation. So the idea, and we also want to make derogations application specific and application broad, which means that, it's like fluoroelastomers in a situation requiring chemical resistance. So fluoroelastomers is somewhat broadens it, but we're also restricting it to where they need chemical resistance, which is the main reason for Viton. So yes, none of your information is shown to anyone else, and when it gets out the other side, it's blended together. So you say, that's your use. When you write down your use to us, that sentence never goes anywhere else. It is literally, we're matching it to a derogation we're doing, and it's the derogation C2 or C5 or whichever is the one that's being discussed. So it'll always be, that's what your use is. This is the broader verbiage we're using it, and we're going to talk about the broader verbiage going forward. When you say the PFOA family, you often mean the PFCA family? Yes. All the chain links. So PFOA is a perfluoroalkyl carboxylate, also called the perfluoroalkyl carboxylic acid, PFAC or PFCA, same thing. Normally, it's the long chain ones that are regulated, PFOA and longer. However, this also includes the shorter versions where we do see PFHXA a little bit, which is the 6-length version. So the PFOA family is itself usually between lengths of 4 and 14, of which today only 8 to 14 is regulated. It sounds like a derogation will still have a time limit. Is that correct? Yes and no. So the 6.5 year one is a pretty set time frame. The 13.5 year is one set for renewal. So the way it's structured, and they haven't quite figured out the details, is if it can't be replaced, it gets 13.5 years, and the idea is to revisit it before 13.5 years. So the time limit ones, when they get 13.5 years, is basically the renewal cycle, about a 14-year renewal cycle. So it's everything has to have a date, but the 13.5 one is the renewal one. There's a recent article I mentioned you could request unlimited. You could request it for sure, but the way they've structured even medical devices, which have no replacement, they make it 13.5. So, and if you look through the derogations today, they have nothing longer than 13.5. Now, one that they might is, for example, in our lab, we have control samples of PFOA and PTFE for calibration purposes. Those ones would go on to infinity. And those ones might get unlimited because they're literally the test control sample to test for these things in the lab. And it's a perfectly good reason why you have it. By the way, one thing I haven't talked about too, even if you get a derogation, there will be reporting requirements ongoing as of about 2027 or so. I haven't seen anything on alternatives for use in vacuum applications, stuff we've seen that can cope with temperature chemicals, too porous for application. Yes, just state why. So what we want to do is say, hey, these are the reasons why you can't replace it, and this is the alternatives. Also, it's this one we're using, and it's not a PFOA risk or a low PFOA risk, and it's the vacuum. We're not touching drinking water here. Or if it's a great PFOA risk, we're like, this is going to take some arguing. But the idea is to compare it, saying, hey, there's no other replacement. This is the advantage of it. It's not just to make things cheaper. It's actually technically viable. It doesn't have PFOA in it. It's not touching drinking water anyways. This is a perfectly benign situation. It's not a phosphate ester. There's no PFAS ester. And so that's one reason why we do the alternatives and all the technical stuff to set the stage. We're like, these ones have no danger. These ones have less danger, and these have some danger. And how to handle it. What does it cost? That's a really good question. It's subject to change, by the way. So earlier is better, by the way. It can only go up from here. It's basically $4,800 per company. If you want other business units to interact independently, it's another $900. Now, this is subject to change. It's probably going to go up, actually. So that's what it is right now. It's a tremendous advantage to this whole system for companies because there's no way you can reproduce this for any remotely near the cost. But it's per company if it's going through a basically single stakeholder. And that stakeholder can distribute as much as they want the company. It costs a little more if you can have additional stakeholders interacting directly because it costs some project management time on our side. If they're commenting and providing uses and stuff, and that's another $900 per business unit operating independently. But the cheapest one is basically $4,800, subject to change, of course. So I would join sooner rather than later. How do we know our uses? Does this imply testing by Claigan? So if you don't know your uses, you need compliance for your products. Outside of this project, we do tons of testing and so on and so forth. And we can, if you don't know what your PFAS uses are at all, we can help you with that. Separate of this project, just please feel free to contact us. Actually, we have to do Maine reporting or the Canadian reporting and US federal reporting, et cetera. Or you're getting questions from customers, or you're worried about PFOA, which is currently banned, we can help you. That's separate of this project. But we definitely can help. We help companies all. That's why we have all this test data. Is we help companies all the time with their PFAS in their products. So feel free to reach out on that. Will economic burden be included? To a certain extent, yes. It's cost is an impact, but it's not as much. We want to say the cost makes it not possible or not possible in time frame. But yes, the cost burden will be part of it. Having to redesign every electronic made in Europe over the next 3 years is a massive undertaking. And I'm sure that a lot of the compliance companies love this, but not just the cost, the sheer ability to do it is not really that feasible. So yes, economic burden will be there to a certain extent. What is the anticipated success rate for derogation applications? Probably pretty good. My biggest concern is actually take our derogation and change the verbiage a little bit and say, that's what you really meant. Like, no, it wasn't. And we've seen that in previous derogations where like, here's the wordage, here's the explanation. They took pieces of the explanation, put in the wordage, and like, you missed something. This is technical. So there's no guarantee, but from experience, it's going to go pretty well. Where we'll have more risk, and we tell people at the time, this one is bleeding PFOA. It could touch drinking water. This is going to be. We're more concerned is that they might take our verbiage and fiddle with it. I'm like, that's not what we meant. So that's actually more of a concern. Yeah, is info@claigan.com best way to get a quote? Yes. Or reply to the webinar one, or email me if you know me. A lot of people know me. But info@Claigan is actually the best way. There are lots of people, and it gets picked up immediately. It's very well integrated in our system. We don't like knitting. Knitting is like trying to do things one at a time. We're very much a factory. We like things that we've done 1,000 times. We can do it perfectly at the drop of a hat. So info@Claigan.com is one of those things. We'd rather be done something a zillion times and be able to do it for you perfectly every time. Will the submission include social impacts of proposed restriction? Yes, as applicable. But definitely. I mean, if it's like there's no impact of it getting rid of it, they'd be like, eh. So yeah, social economic impacts always have a portion of this. Some are blatantly obvious. often it's really identifying to them the magnitude versus the risk they're preventing. So you want to really, this is what you're going to make people do. This is the harm you're going to cause, and this is the advantage. So in some cases, there was some low-hanging fruit. Like if we got rid of that, we get rid of most of the PFOA problem. Yes. And there are alternatives. Yes. Well, that seems like a good idea, as opposed to like the number of applications for PTFE. It's especially medical devices, absolutely biocompatible, very low friction. So if you're putting up a catheter up my artery down there to get to my heart through my leg, and you have a choice between material that has no friction and is completely biocompatible and it doesn't leach anything in your body, with the one that kind of sticks a bit and leaches stuff in your body, I want the PTFE one. I want the first one. So there's some really good uses of this. And then sometimes it's really also useful to be very, very illustrative. So if you had a choice and you were on the table and you had these two catheter choices, which one do you want? Do you want the low friction one that doesn't leach in your body, or do you want the one with a bit of friction, a bit of a grip as it goes up your artery, and it'll leach a few things into your? Which one do you choose? PTFE is the first one, by the way. So that socioeconomic impact is really important, but also being illustrative, so it's very tangible for them. Are there any other regions that are already investigating PFAS and may make mandatory restrictions before the EU one? Yes, US states. They're almost all the same, though. They went a little sideways. Most of them are trying to ban PFAS in food contacting materials, which is pretty funny. So, like an example, we had taco bowls for Lunch and Learn. We host Lunch and Learns internally to learn things. And the taco bowls were great, wonderful. Nothing leached through these paper taco bowls. Well, they're fluoro-coated. Pretty safe, actually, but that sort of thing they're banning. So there's a lot of state level ones. They're all banning kind of the same thing. Minnesota might be getting a little carried away with PFAS in food contacting regions. But we're looking, most of the bans right now are very application specific, fabric and food packaging and stuff like that, and often at a state level. So, and they're often very refined, like banning, like in other things, banning plastic straws. Humorous thing, when they banned plastic straws and they went to paper, paper is miserable straw, just doesn't work at all. The way you make a paper straw work is you fluorocoat the inside, then it works fantastic, which creates a different problem. Were perfluoroelastomers to be included? Yes. So fluoroelastomers, I'll describe later that fluoroelastomers, I'm really mean perfluoroelastomers. I'm going to describe, and this could be a range of a huge number of things. I want to be as all-encompassing as I can, the fluoroelastomers. They're all usually a soup of vinyl butene fluoride, but can be other things. We just want them to be the non-ester one. Possible. And we want the verbiage to be broad. We'd rather not say, hey, this cast on, but we'd rather say fluoroelastomers. We'd also call them perfluoroelastomers, same thing. Are the derogations available for anyone to use, claim, on or before the compliance date? Hopefully they'll be published. So they should be published in the final version, and then you can use them. There aren't numbers proposed right now, but they're very application specific. Are there any standardized tests with the EU qualified for detection of PFAS they want to restrict? For the PFOA, yes, there's a very common test for that one. We're in discussion. There's actually a big survey going on with Kemi in Sweden, their enforcement authority, on test methods. We've had to invalidate combustion bomb. We have enough interlab data now to show that it can't see 50% of the PFAS situations in physical products. It's really good for fabric, and it was great for solid materials, but finding fluorine and PTFE is pretty easy. It's like 30% of the concentration. It's not very good at low ppm surface coatings, which is about 50% on plastics and rubbers. It can do fabric, but it can't do plastics and rubber. I had to like downgrade combustion bomb. It's actually, for us, it's validated now. We can't use the method because we've enough test data now to know that it misses roughly 50% of the PFAS situations in articles. So we've had to downgrade it. So the test standards are still on the go. The best one is the WD XRF that we use for fluorine detection, for polymer detection. And then if we detect a polymer, there are situations, we have a lot of data now, where there's a risk. When we find a PFAS, it's only about 10% of the time there's a PFOA risk. It's for technical reasons. And then we use LC. Mass spec for that. Will testing be required for this project? No, the testing's great. We have a lot of test data ourselves. I definitely recommend testing for fluoropolymers as the fastest way to go through your product and most accurate, because suppliers don't generally know what's in it. That's really good. What about perfluoropolyether lubricants with and without PTFE? That is a separate question. We will be definitely looking at mineral oil or silicone oil with PTFE suspended in it. But other lubricants, we need feedback. Definitely the one we see mostly is a mineral oil or silicone oil with suspended PTFE. And suspended PTFE in it is not a PFOA risk, and it's wonderful use and application, etc. But if there's really technical specific ones, are things to include on your uses. Do you have any which products you'd like to include, meaning which products you have the most test data on? It's amazing what we have test data on. It could be a pump, it could be a computer, it could be a medically invasive device, it could be a medical generator, it could be a TV, it could be a chair. We're pretty agnostic what comes through here. And so the thing is, our data will be flavored in percentages a little bit by what we see. But it's incredibly broad spectrum. We don't bias it, so we get whatever comes in here. When in doubt, you don't know what's in your product, separate of this project, we'll take care of it for you. Really help between this or any other regulation, we'll help you out. Oh wow, look at all the questions. Sorry, I'm going a little bit over time. I'll go a few more minutes. Which analytic test technique is most suitable for testing for PFAS? So no fluorine, no PFAS. WDXRF is by far the best. It's not commonly available. We have it. It's fantastically better. It's cheaper and faster and way more accurate than the other, which cheaper, faster, and better is what we like. There's always a better way. It's fantastic. If you're doing PFOA in a fluoropolymer fluoroester, you're using LC mass spec, tandem mass spec. I've already tested most of our products. We require more information or samples. Older ones, but we can kind of, for your main uses, we can usually project. However, you may want to update, especially PFOA restrictions. When to just reach out. The engineer you've been talking with will help you out. Or if you don't know who it was, just go to info. But the engineer, if you're working with us, there's always an engineer in direct contact. They will have an answer for you. By the way, when you do testing with us, it's not a nameless face. You'll always have an engineer who will literally not only give you the testing, but explain it and be there for any questions. Will Claigan take care of any future reporting requirements? So after this, if there's value, we may do extended projects after this to support more questions or so on and so forth, but only if there's real use. In terms of the companies we work for normally for testing, et cetera, consulting, we support them ongoing all the time. Do hydrophobic membranes and coatings contain PFAS? They often do. Anti-fingerprint often do. Depends what they are. Hydrophobic membranes can be two things. They can either be a PTFE emulsion coated on, or more likely it's expanded PTFE, like Gore-Tex, and expanded, which is really an irradiated PTFE expanded as a fiber. But it depends what it is. Our test equipment sort that out. Our PCB process is affected by PFAS regulation. You don't have that many PFASs on a circuit board. There are a few exceptions. One of the biggest ones is often the transformer has little wires that come out of it, and they have little tubes on them. They're often PTFE tubes for whatever reason on the wires coming to the transformer. So circuit boards don't often have a lot of PFAS. If you have a coax connector or an antenna, they'll have it in the core. It's usually the other pieces. The flame retardant on the circuit board is not normally anti-drip. It's different, however, it's more likely to be in the housing around the circuit board or around the power supply or around the fan. The fan has housing almost always, not always, half the time has PTFE in it as the anti-drip for flame retardancy reasons. Well, thanks everybody, way over time, and I apologize for that. If you have, and I didn't even remotely get to all the questions, sorry about that, I didn't get to yours. Please feel free to reach out, and of course, reach out to anyone here. I'd be happy to help, and it's a pleasure hosting everyone. And everyone who register receive a copy of these slides. And I look forward to talking to everyone again soon.